All right, so we got here our wonderful Jeopardy review game. I'm going to go through it pretty quickly, and some of these are easier than others, and we may not even do all of them depending on how long this video gets. So first, we're looking at geometric series and sequences, little vocab check, the ratio between each term. In a geometric sequence is the common multiplier. We usually just use the letter R for that. So common ratio, common multiplier, the letter R. Got it. Okay, next one. Oops, there we go. We'll make it work. The general form of a geometric sequence. Well, that means you're looking for a formula to get to any term you care about. And what you do is you start with the first term and you multiply by the common ratio over and over again. You multiply by it n minus 1 times. Okay? You don't multiply it n times. That would get you too far. If the one way to think about it is the first term has 0 multiplications. It takes 1 multiplication to get to the second term. It takes 2 multiplications to get to the third term. It always takes 1 fewer multiplication to get to term number n. So that's what we mean by general form. It's a formula that gets you to term number n. All right, here, what's the missing term in the sequence? Well, we're in the geometric sequence pattern, and I can tell that we are dividing by 2 every time, or equivalently multiplying by a half. That means this number needs to be 10, because that fits the pattern. All right, the sum of the first 10 terms in a geometric sequence series here. So when you have a geometric series, you do the first term, and then you have r to the n minus 1 over r minus 1. When I look at these numbers here, I can see that each successive number is multiplied by 1/3. And the first term is 3. So I know that my sum of my first 10 terms means I've got 3. I've got 1/3 to the 10th minus 1 over 1/3 minus 1. Just type all that in. I'm going to show it to you on the calculator because you got to be careful with how you set up your parentheses. So 1/3 to the 10th minus 1 over. All right, so look at how I set this up in there. Notice that when I did 1/3 to the 10th, I put it in parentheses. That way the calculator knows it's the whole fraction being raised. I also put the top and the bottom of the fraction in parentheses. So the most common mistakes that I see are people either forget this parenthesis right there or these parentheses on the denominator. So we get about 4.5 as our answer. And the 501, the sum of all terms. So we're going to go all the way up to infinity as we go through this one here. If you set up your formula again, we're going to add up an infinite number of terms starting with a half. Common ratio is a half. There's an infinite number of them, all like this. If you raise a fraction to a really big number, you get a really small answer. So what we say is a half raised to the infinity power is 0. So we really just have a half times negative a half over negative 1 over negative a half. That is a half over a half. Negative over negative is 1. Okay, there we go. So that's it for the geometric series and sequences. Let's go on to compound interest. Well, this first one, the idea of taking a percent as interest and adding it to the principal repeatedly, that is just the definition of compound interest. The handy tool that you can use probably, this is your finance app on your calculator. So please remember that right here on your calculator, we are in math apps. You press the apps button right here, and it brings up your apps menu, you're going to do that finance app on the first one. Hit enter and enter one more time. And then you have all the information you need to solve these sorts of problems. For 300, the equation for future value. So future value, when we're talking about compound interest, is your principal 1 plus r raised to the n. For this one, your future value is going to be 10,000 1 plus 0.08, because that's 8%. You got to divide it by 100 raised to the 10th power. You can also do it on your calculator. All right. The interest accrued after investing at a rate. So we could do this one here with the formula, or we can use the finance app. So let's do the finance app here. So N is 5 for 5 years. I is 3. PV is 3,000 because that's what we start with. PMT, payment, is 0. Future value, we don't know, and we're only doing it once a year. So I don't know what the future value is. So I'm going to ask it to solve the future value. I have it highlighted, then I do the green button and the enter button. And I get this number here of 3477. Now that does not mean that we are going to earn that much interest. The 3477 is what the future value is. 3477.82. Take away the principal of 3,000, get your 477.82 as a remainder there. Great. And then the last one in the compound interest rate as a percent after a total is accrued with an initial value of 20,000. So we'll go through here. 10-year period, don't know interest, present value is 20,000, no payments, future value is 25,000. So we set it up like that. We ask it what the interest rate is. So we go green, enter. Oops. Oh, that's right. So when you're depositing money into an account, it should be a negative number. And when you are withdrawing money, it should be a positive number. So I'm going to change my present value to negative 20,000 like that. Then I'll ask it to do the interest rate. There. It tells me 2.25%. So just remember that your PV and your FV, when you're putting money into the account, it's negative. When you're receiving money at the end, it's positive. Otherwise, the calculator gives you an error. All right, now we're into the next one, annuities and amortization. If we are making regular account payments into an account to increase the amount, then that's annuity. Annuities are when you're putting more money in and you're getting more money over time. Now, if we are decreasing the payments, that's amortization. That means you took out a loan and you're paying it back over time. Okay? So annuity means you're putting more into savings. Amortization means you're paying off an initial loan. Okay, now we can go back to our good friend, the finance app. The number of payments needed to pay off a $1,000 loan with an interest rate of 3%, so I is 3. $1,000 loan, so PV is 1,000. Payments is $200, so it's $200 per year. And think about what the future value is. Well, if I'm paying it off, that means my future value is going to be 0. And the question asks for the number of payments. So I have N up at the top highlighted, and I'll go green button, enter, and it says, okay, why did I get a wrong answer here? The reason I got a negative answer is because I put a positive payment in there. That's not how it works. I'm paying that money back. So I should make this into a negative 200. So see, you got to be careful with putting the right positives and negatives on there. Otherwise, you get goofy answers. So that couldn't have been negative 4 payments. That'd be a pretty cool loan. So now that I put the PMT as negative 200, then it knows I'm paying $200 back. So I'm going to ask it to recalculate. And I got 5.49. And that kind of makes sense because, 5 payments of $200 is going to be $1,000. The extra 0.49 is to pay off the interest that accrues over that time. So really, it would take me 6 payments to pay it off. Just that last payment is going to be less than the previous 5 payments. And this is something that happens in real life. If you get a loan and you see like an amortization schedule, the last payment is often less than the other payments because that's paying off whatever was left over. Okay, the amount of money in the bank after regular payments of $40. So I'm going to make my payments 40. And this is actually money that I'm earning. And it had an account that started with $100 in it, interest rate of 2% for 10 years. Okay, so check out how I set it up. 10 years is N, 2% is I. PV is negative 100 because you put that money in the account and you're putting 40 more dollars. So those are both going to be negatives. And I've got FV highlighted because it wants to know how much are we going to have at the end. So this is an example of an annuity. Looks like we'll have 559 at the end of 10 years there. Okay, so 10 payments of $40 is 400 plus the 100 that was in there is 500, and then you can see that the extra 59 odd dollars is interest. All right, almost done with annuities and amortization. The payment amount per month needed to pay off a loan at 12,000, interest rate of 2% per year in 10 years. Great. So we've got a couple of those things in there already. 12,000 pay off means future value is 0. So here's how we're set up. 10 years, 2%. The reason the PV is positive is because I received that loan. That was money that came to me. The PMT is going to come out as a negative number. So I go green, solve. So apparently I got to pay that much, $1335.92 a month, or not a month, excuse me, a year for 10 years. 10 payments of that is going to be, $13,359, and so that shows the amount that you pay on interest. If you take this number and times by 10, the payment times 10 is your total amount that you paid, and then you can subtract the principal and you know your interest. All right, almost done. Exponents and logarithms. The inverse of an exponential function is a logarithm. Don't be scared of the word logarithm. It just means inverse exponential. The asymptote of the equation. The asymptote is that flat line. So if you draw a graph, every exponential equation either looks like this or like this. And so there's this floor, this asymptotic floor right there. That's what the asymptote is. It turns out to be that value right there. So we say y equals -3 because that tells me the line that it never crosses. That's the asymptote. Exponential function. So here we've got a log with a base of 15. So what I can do is put a base of 15 on both sides. Logs cancel bases. So I have 200 is equal to 15 to the x. There we go. So just switching between the two forms there. Last one, or not last one, second to last one, the value of x here. So I can just do the log of both sides to cancel the base of 10. It's optional to write a 10 here. If you just write the word log, it implies a base of 10. So the log button on your calculator, log, right there, log 965, tells me that, 2.84. Now we're on the last one. The number of minutes, okay, we're doing a word problem. Number of minutes for a cup of tea to become 35, starts at 100, 10% a minute, room temperature is 20. All right, so we got a bit of a doozy here. So here's the cup of tea. It cools down at 10% per minute. So it's keeping 90% of its temperature here. All right. And it starts out at a temperature of 100, which is 80 above room temperature. So I set that up kind of quickly. When you think about something cooling down, room temperature is going to be the asymptote. We're going to see our cup of tea go down like this, and room temperature is the asymptote. So I knew that 20 had to go right there. This initial value right here of 80 is always related to the asymptote. So when I read 100 here, I had to break that up to be 80 plus 20. And now the question's asking me, oh, and I did 10%. If you lose 10%, you have 90% left over. What we need to do now is solve for when that's going to equal 35. So solving that, take away 20 from both sides. 80 times 0.9 to the x is 15. Divide both sides by 80. So 0.9 to the x is whatever 15 over 80 is, 0.1875. I do the log base 0.9 of both sides. Remember, you can do math, alpha math, to get log base 0.9 of 0.1875. And that's what it tells me. So that means that x is 15.888. It's going to take just under 16 minutes for your tea to cool down to 35 degrees Celsius. Okay, so that's it. Please let me know if anything is confusing. I'm happy to help out.